Hello there, in this lesson we're going to learn about function notation. Like with most mathematical subjects, we don't like to use lots of words. Instead, we apply the use of symbols and abbreviations so that we still know what we're talking about. Now, a function is usually written using a variety of mathematical notation, which is why we're going to spend a little bit of time to get to know each of the different types that exist. When writing a function, we know that we use the most common letter of f, a small lowercase f, and that denotes the use of a function. Remember, denote means describes or labels a function. So we name it the letter f most commonly, although other letters may be used. If there are more than one function in a question, for example, you might have a function f, a function g, and a function h. Or actually you could have any letter at all, but you'll notice f, g, and h being used more often than any other letter. Now, when it comes to the inputs, which you'll remember are the elements that we put into a function, so what we start off with before we perform any calculations. Well, of course, the inputs will change. We might have several different inputs that go into one function. So that means that the element will vary. It's a variable. We can't say it's always going to be the number 2, for example. We might have the inputs 1, 2, 3, 4, and 7. So, like when we have any kind of variable, or when we're not certain of what a particular number is, we can give it a letter instead. And for an input, we use the letter x. So each time you see the letter x when we're referring to functions, it means the input. So for one input, let's say the number 1. X will be the number 1. If the input is 5, then x is the number 5, and so on. Now for the outputs, we can use the letter y, and you will see that we have what looks like a letter F, a bracket with an X inside it, and a closed bracket. Now, both are just as common as each other. It may definitely appear easier to use the letter Y to represent our outputs, but it's very common that we see this symbolic notation, and we would pronounce this by saying f of x. And the f refers to the fact that it's a function and the function's name is f. So of course it could also be g of x or h of x. So this letter in front of the bracket is the label for the function's name. And then inside the bracket is simply the x that represents the inputs. So it's almost as though we have a function and it's a machine and we're going to put these x's inside it. And that actually helps us to understand because we've looked at functions being a machine before already. Suppose you write, and we have f of x equals x squared. So what this means is, that we have a function called f and that we put inputs into that function. And the inputs we're just going to say are the letter x because they might change. We might have more than one. Now our answer then, hence the equal sign, will be that x is squared. So what this is actually telling us is that to get the outputs, because f of x, this symbol notation together represents the outputs are the inputs squared. it's telling us that this function has the rule to square the inputs. So you have just defined a rule for a function f that transforms or maps any number, the input, onto its square. If we started off with the number 4, for example, as an input, then the output would be f of, and instead of x, we know what our input is that we're dealing with. So it's the number 4. F of 4 equals 4, that same input, squared the number 16. 4 times 4 is 16. Let's consider the following inputs for this same function f. And here we have a set of all the inputs. Can you remember what we call that? It's the domain. The domain consists of 4 inputs, -1, 0, 1 and 2. So these are the numbers that we're going to start off with that we put into our function. So we are going to be squaring each of these numbers to find our outputs. And the full set of outputs was called the, can you remember? The range. Let's use an input-output table like we learnt in the previous video to show our outputs for this function. Remember, you have 3 columns. We have our inputs, which we're now learning today. We also denote with the letter X. Then we have our rule, which is simply what we do to our input in order to get our outputs. So our rule is x squared. The inputs are squared. The input is times by itself. And then our third column is for our outputs, which we know are now called y. Or, of course, f of x. We could use this symbol instead in our title. So we're going to list each of the inputs, one under the other, and we're going to perform the calculation, the rule in the middle box. So you'll notice that we start off by simply writing the rule again, but we know what our inputs are now, so we're not going to be keeping it as x squared. X is simply the input, so for this box here, the input is -1. So inside our bracket is -1 rather than x. The input is -1, and that needs to be squared to get our output. Squaring means multiplied by itself, so we have -1 times -1, and we know that 2 minuses make a plus. So the output is the positive one. When the input is 0, that means we change the x in our rule to 0, and it must be squared. Well, 0 times itself is still 0. 1 becomes 1, and the input 2 results in the output 4. We can represent the rule for this function in a number of other ways as well, and each of them are important, so we must focus very hard and try to learn them all. This is the first option that we've looked at already, and we pronounce that by saying f of x equals x squared. Now, alternatively, another way to notate the same function could be either instead of having a bracket around the x, we have a colon in between the f and the x. And instead of an equal sign, we have an arrow to show that the function has the rule of this. Now, it also is a bit like the mapping diagram where we had arrows to show that an input maps to its output. So we can simply still say that there is a function f, inputs go into it, and then what must be done to each of those inputs happens after the arrow. So the rule is simply written after the arrow. So in our function f, our inputs are mapped to their inputs squared. So this first part is another way of writing the exact same thing as this above. And then we have a third way too. And unfortunately, all three could appear in exams. So we do need to be comfortable with recognizing all three. Now, the difference between this third option and the second one is that instead of a single arrow, we have this little square end on the arrow, but it means the exact same thing. It's still a function and the letter here, which of course could be F, it could be G, could be H, but we have inputs that go into it, and then what comes out is, and then we have our rule for our function, the calculation. So our inputs will be squared. And we would read either of these two as f, the name of the function, maps, so the arrows refer to maps as opposed to being equals. It maps x, our input, to x squared. So both of these two, they look slightly different, they read the same, and they mean the exact same thing as our first function notation example. Now this time, instead of using f of x, we're using the y to represent our outputs. And we know that our output is as a result of our input being squared. So y equals x squared. Now we know that the couples or ordered pairs are the sets of all the inputs followed by their unique output together in a bracket separated by a comma, and they're all then separated by commas inside a pair of curly brackets because they're the set of all inputs and outputs. So for our function f, when we started off with the input -1, it had the output of +1. When -1 was squared, we got the number 1. So the first numbers in each of these brackets are the inputs, and the second numbers in the brackets are the outputs. So the input 2 had the output 4. And here is our complete list of couples or ordered pairs. So if we were asked to list the ordered pairs for a particular function with a domain of -1, 0, 1 and 2, this would be what our answer would look like. Let's use our mapping diagram. We have two ovals. The first represents our domain, our inputs. The second represents our outputs. And in this case, the codomain and the range are the same. All of the elements in this oval are outputs, actual outputs. Now you'll see that both -1 and +1 had the output 1. So this function is an example of many to 1. So many inputs are resulting in 1 output, and that's absolutely fine. So just to recap, in a function, two inputs can have the same output. For example, the inputs -1 and 1 both have the output 1. However, one input will never result in two outputs, so we can't have 1 to many. And every input has its own output. Let's have a look at some examples that we might find in an exam. A function f is defined as, and here you see that we have the symbolic notation to represent our outputs, f of x. So our outputs are as a result of the following rule for this function. And the rule for the function is that we must multiply our input by 2. So 2x means 2 lots of x. And x is our input. So 2 times the input, and then we must add 1 to it to get our output. It then says find, first of all, f of, and instead of having x inside the bracket, we have the number 4. That means that we know what our input is and that the input is 4. Remember that x represents the inputs. So if we don't have an x there, we have a number instead, it means that we now know which input we're interested in. So for this function, whatever our input is, and we have the input 4, we must multiply that by 2 and then add 1. So this is asking us to find out what the output is when the input is 4. So let's have a look. We change the x to the number 4. The input is 4. And we know that 2 times 4 is 8. And 8 plus 1 gives 9. Now your answer for your homework, for class tests and any exam must start off using this notation that appeared in the question as well. So you must have full workings for all your work. You must have f of and then the number that we've been asked to find. So you've copied f of 4 from the question, and then you have shown your full workings of how to calculate the answer, and our answer is the number 9. Let's look at B. This time our input is -3. So we know that f of x equals 2x plus 1. We just start off by writing the name of the function out again. And now we're going to change the x, the input, to the number -3. So f of -3 is 2 times -3 plus 1, which means 2 times -3 is a plus and a minus. They're not the same signs, so the answer is negative. And 2 3s are 6. So -6 plus 1 gives the output -5. So when the input is -3, this function with the rule 2x plus 1 gives the answer -5. Now this time we have h, a function. Remember how we said that it can be any letter, but most often than not, it's f or then g and h. So here we have a function called h, and we're using the alternative function notation to show how we get the outputs for this function. H maps x, the inputs, to 4x minus 5. So in order to find our outputs for the function h, we must multiply our inputs by 4. 4x means 4 lots of x, 4 times x. So we multiply the input by 4 and then we take 5. And this has been shown on the mapping diagram. Now you'll see that there are some letters appearing, and the letters are for us to work out what those numbers actually should be. So let's have a look at the input number 2. So instead of having x in our functions rule, we know that the input is 2, so x is 2. And we know that we have to multiply the input by 4. So let's start off by writing that h of 2, when our function h has the input 2, it gives the answer p according to our mapping diagram. But we simply know that the rule to get any output is 4x minus 5, which means 4 times 2 in this case, because our input is 2. And 4 times 2 is 8, and 8 take away 5 gives 3. So therefore, P on this mapping diagram represents the number 3. P equals 3. We do the same thing then for our input minus 3. We're going to start by writing that h of minus 3. In our function h, if we have the input minus 3, we get the answer q. But we know that the rule is 4x minus 5, and our x is minus 3. Remember, the x simply means our input. So 4 lots of minus 3. A plus and a minus when multiplied, they're not the same sign as each other, so they're going to not get on. There's going to be a minus outcome. So minus 12. And then we need to take another 5 away, so we end up with minus 17. So when we put the number, this should be minus 3 here. When we have the input minus 3, the output is minus 17. So on this diagram, and it says P as well, that should be Q, apologies again. So this Q is minus 17 and P was 3. Now, to find R, that's a little bit more challenging because it's actually the input that's missing. We've been given the output, the answer. So we've been given the answer to 4 times something and then take 5, and that gives the answer 7. So like always, if we start off with the answer, we're going to work backwards to work out what the starting point was, what the input is. So we know that when the input is, and all we know at the moment is that it's R, an unknown, the answer is 7. So that means when we multiply whatever that unknown input is by 4 and take 5, we get 7. So let's start by adding the 5 back on first. If we took 5 away and got 7, let's add the 5 back on, and that means when we just multiply the input by 4, it gives the answer 12. So if we want to just one lot of our input rather than 4 lots of it, we can divide that 12 by 4 and we get the answer 3. So the input 3 has the output 7, and we can verify, which we know means check our answer, by putting the number 3 back into our original rule of our function. So 4 times the input, take away 5. Or 4 times 3, if we're correct, the input 3 is 12, and 12 take away 5, it does give the output 7. One last thing before you go. Why was the equals sign so humble? Why? Because she knew that she wasn't greater than or less than anyone. Thanks for listening. I'll see you in the next video.